Hello students, how are you? I hope you are fine at your home. Tell me that video you are watching, whether you are preparing the notes or not. Don't neglect number of videos we are preparing. You have to take interest and watch the videos that we are uploading in our channel Chemistry Goal, and be sincere, be punctual, without taking late. Watch the videos and prepare your notes, so it will be very much helpful for your examination. So dear students, today we will discuss two extraction of copper and zinc. Extraction of copper from copper pyrite ores we will discuss. From copper pyrite, that is CuFeS2. From copper pyrite, how can you extract copper? Let us discuss. We know the general methods in the extraction of metals. That first is crushing the ores to powder form, then concentration of ore. As it is a sulfide ore, so the ore is concentrated by froth flotation process. Already we know the sulfide ore is concentrated, is purified by froth flotation process. In this process, already we discussed in the last video that the mixture of oil, water and sulfide will be taken in a tank where the air is fast. During the mixing of this, when air will blow, then during continuous stirring, a foam is formed, that is called froth. That froth floats on the surface of the water. This is called froth. This is called froth produce. Froth bubbles containing the sulfide ore floats on the surface of water, then it will be collected, then the air will remove, then pure sulfide ore will be collected, then dried. So this method already we have discussed in the last video, that is what is the froth flotation process. So in this way the copper pyrite ore is purified. Then next step is conversion of sulfide ore to oxide. Then this method is called rusting. In the rusting, what happens, the mixture of that ore containing impurity will be heated with sufficient oxygen. Then here what happens, during heating, some volatile impurities and impurities like your sulfur, phosphorus, arsenic present in the pyrite ore are removed in the form of oxide. Sulfur converted to sulfur dioxide in the gaseous form removed, then phosphorus converted to phosphorus pentoxide also removed in the gaseous form. Okay, so sulfur, phosphorus, arsenic convert to their oxides, and some volatile impurities present removed, and moisture also removed. Then the pyrite, that CuFeS2, copper pyrite, gets oxidized to sulfide, convert to sulfide. So pyrite dissociates in presence of oxygen, convert to copper sulfide and iron sulfide. Then during the oxidation, this iron sulfide and copper sulfide gets oxidized by corresponding oxides, iron oxides and copper oxides. So ultimately during roasting process, the volatile impurities, some impurities removed as oxides and moisture also removed. Then copper pyrite, this sulfide ore of copper and iron gets converted to dissociated into sulfide, copper sulfide, iron sulfide. Again these sulfides gets oxidized to iron oxides and copper oxides, because our aim is to convert sulfide to oxide during roasting, so that the reduction process will be easier to get the metals. The next step is your smelting. This is also very important process methods. It is done in a blast furnace, that is smelting process. Smelting process generally it is the formation of slag by reaction with impurity and flux. That means when impurity reacts with the flux, forming slag. But impurity and flux, they differ in properties acidic and basic nature. If one is acidic, other will be basic. So that slag is salt fusible product, light mass separated by the reaction of impurity and flux. Here what happens, when this roasted ore of copper pyrite it mix with coke and silica. Here what happens, silica mainly uses flux, silica uses the flux, and here impurity is, we can say, iron oxides, because our aim is to extract copper metal. So iron oxide present with copper oxide, it is called as impurity. So it should be removed from the copper oxides. So what happens, so silica as a flux is used, here impurity is iron oxide. So impurity is iron oxides and flux is silicon dioxide. When they heated during the smelting process, a slag is formed, that is called iron silicate. That is slag, a fusible light mass substance is produced, that is called slag. It floats on the surface of the metal, molten metals. Then here what happens, during the smelting process, some unreacted iron sulfide and copper sulfide remain. During the roasting process, during the oxidation process, unreacted iron sulfide and copper sulfide remain with copper oxides. This iron sulfide copper sulfide mixture is called copper matte. It is called copper matte. This unreacted iron sulfide copper sulfide mixture present in the copper with copper oxides, that's why it is called matte, copper matte. And this copper matte, when it will heated, as it contain copper, so how can you get copper from copper matte? Now it is done in Besomarization method, that is Besomar converter. This is called Besomar converter. Here it is a steel tank. Here what happens, the mixture of copper matte is taken and strongly heated with hot air. When hot air will pass into the chamber, when this chamber hot air will pass, then the copper matte containing copper sulfide and iron sulfide reacts. Here what happens, iron sulfide convert to iron oxides, iron sulfide convert to iron oxides, and iron oxide and silicon dioxide is convert to already slag. It is already convert to slag, irons, that is iron silicate. Then during the heating, here copper sulfide is convert to copper oxides, because copper sulfide iron sulfide mixture remain. Then copper oxide is produced, then unreacted copper sulfide, these two, copper oxide converted copper oxides and unreacted copper sulfide both reacts. Then what happens, a reduction, self reduction takes place, so convert to copper, then ultimately you will get copper. So copper that is produced, it is produced in the form of molten copper. Then this molten copper, when it will be cooled, when the temperature decreases, then what happens, during solidification what happens, SO2 gas is produced from that copper, forming a blister on the copper. Blister means small holes created in the solid copper, that is called blister copper. This is called blister copper because having small holes, because the gas SO2 is produced from the solidification of liquid copper. Then what happens, it forms blister, that is called blister copper. So for main first thing is we have to convert the copper pyrite to copper sulfide, iron sulfide by dissociation method, then roasting, then smelting. Then during smelting the ore, that is iron oxide, main objective is to remove the iron oxide from the copper pyrite, because we have to collect the copper, not iron. So that iron oxide will be removed as iron silicate in the form of slag. Then unreacted copper sulfide and the converted copper oxide both gets heated, then due to self reduction forming copper. This step is very important reactions, then forming copper. So copper is obtained in the form of molten copper. During cooling, during solidification, it will release as SO2 gas. This SO2 gas forms a blister in the copper. That's why it is called blister copper. Okay, so this is regarding the extraction of copper. Then how can we refine the copper? As the copper produced during the extraction, it may contain impurity. It should be again purification required. That is called refining of copper. Already we have discussed in the last videos that copper can be purified by electrolytic method. Already a low reactivity metal can be purified by also electrolytic method. In this method, what happens? Already discussed that impure copper used as anode and pure copper used as cathode. These are two basic principles. Then the copper sulfate used as electrolyte, that is copper sulfate used as electrolyte, copper sulfate solution. Then when DC current is passed, then what happens? Copper gets deposited at the cathode. Pure copper are deposited at cathode, then the thickness of anode decreases due to dissociation of copper to copper ions. This is the reaction test. First, copper sulfate dissociated into copper and sulfate ion. Then at the cathode, what happens? Copper deposited in the form of copper, solid copper deposited, but anode what happens? This copper ionized to copper ion. So in the anode, copper ions produced, in the cathode, copper deposited. So just one side, the thickness of anode decreases, and in the cathode the thickness decreases. This is the oxidation and reduction reaction of copper electrode containing copper sulfate solution. So in this way, the impure copper can be purified. Then next is, what are the alloys of copper? Already we have discussed that different metals have different types of alloys, because due to better quality, due to better properties, superior nature of alloys, we are converting metal to alloys. What are the alloys of copper? One important alloy is brass. Brass is made of copper and zinc. Already we have discussed. It is used for utensil and cartridge caps. And bronze is made of copper and tin. It is used to making statue. Then bell metal also, that is copper and tin, but percentage differ. But you see, bronze is copper and tin 90 and 10%. Here bell metal is 80 and 20%. It is used for making bells. Monel metal, that is copper, nickel, iron, and which one? Manganese, is mainly used for acid container. They do not react with acids. That is monel metal. Then gun metal is copper, tin, and zinc, mainly for making bullet, gears, and bearing, like this. Then German silver is copper, zinc, and nickel, and percentage are different percentage, and making for utensil, resistance wire, like this German silver. Then aluminium bronze, that is copper and aluminium, jewelry and paints. So these are the some important ores of that is alloys of copper and their composition and their uses. So you have to remember this. This is very important for your computer examination. In JEE and NEET also, question are asking, some direct question asking what are the composition of alloys. Then next part is extraction of zinc. Zinc can be extracted from zinc blende, that is zinc sulfide. By same common method it can be used, that is concentration method, that is using froth flotation. Already know, as it is a sulfide ore, it can be purified by froth flotation method. Already you know the methods. Then alpine oil is used, already we have discussed. Then roasting of concentrated ore, as it is a sulfide ore, it should be roasted. During roasting, already we have discussed, some volatile impurity removed and the moisture is removed. If contain moisture, then wet. If ore is wet, it should be dried, so moisture removed. Then third step is, after roasting, the third step is reduction. Mainly zinc oxide is reduced to zinc by carbon reduction method. The method is called carbon reduction method. Carbon reduction method. In this method, carbon used as a reducing agent. During heating of zinc oxide, taking the mixture of carbon and zinc oxide on strongly heating, then zinc oxide reduced by carbon to zinc, then zinc is produced. Then zinc will be collected in the form of molten zinc. Then one already know, as zinc has a low boiling point, it can be purified by distillation method. During heating, during distillation method, the impurities like cadmium, lead, iron can be removed, so that zinc, as it has a low boiling point, it can be separated fast. So by distillation method, zinc can be purified. And the metal containing impurity of zinc is called spelter. The crude metal, that is metal containing impurity, it is called spelter. Spelter is the impure zinc, and it can be purified by, already we have discussed, by distillation method. As it has a low boiling point, it can be separated by distillation method. It can be purified, it can be refined by distillation method. So these are the very important methods in the extraction of different metals. Today we discuss the extraction of copper from copper pyrite and extraction of zinc from zinc blende, that is zinc sulfide. So common method we have used. So try to remember and practice the reaction, the chemistry of the extraction process, metallurgy of the, that is chemistry of metallurgy of different extraction of metals, and practice it, and try to remember different alloys of metals. And if you have any doubt, you can send your questions, your doubts in the comment box. Okay, so if you like the video, please share the video to your friends and your relatives, and don't forget to subscribe the channel. Okay, thank you.